Okay, so this video is about a magnetic XY grid to do robotics with, to do big box robotics with. So I was thinking about my bed and making my bed and how that's really hard. And then I had the idea that you have these rails that come out of the wall. These rails that come out of the wall go over your bed and um, pull the sheet up onto your bed and up into the wall. And then presto, with a big box, rails in the wall, along the wall sort of idea, you got a way to make your bed now, which is an otherwise almost impossible task. See, what I was saying earlier to myself is that the problem with robotics, is that they're not using machines. They're not using machinery. They're not using automated machinery or remote control machinery. But they're trying to use robots, and that's never a good idea. Robots aren't that great. They're slow, and you need specifically designed machinery, and more so a big box theory, a big box understanding of how you want things to be. You have to design things for robots to use, and you have to design things for robots to make, and you have to design things back and forth with robots and back to your platform and back to the robots again. So, so what I was thinking is there's like it's like a computer keyboard where you press it a million times. You have to you have to you have to basically run competitions and shoot out competitions and have call outs to see who can make the best computer keyboard, so you can get a million presses, so you can get 100 million presses on the keyboard and it doesn't break. And usually simplicity wins. Usually simplicity wins when you're trying to make it 100 million times without it breaking. And that's the same with simple mechanics. And basically, you want to use mechanics that are simple. And this is a great simple idea. It's a magnetic rail system. So similar how you have like an overhead crane that's on a rail system. This is where I was thinking, where you have these rails come out of the wall. You now have a rail system, right? You have an X-Y axis that these rails are traveling upon. What if these rails were magnetic? Now you could do this ultra fast because we all know that magnetism and electricity are attached, and pretty soon we're going to learn to jack magnetism and electricity and get these things going at the speed of light with switches. So you already see trains and stuff and other magnetic and hovering magnetic cargo pipelines appearing, and magnetic already is really fast. So this is about building an XY axis that is magnetic, where the whether it's a robotic arm, whether it's accessory and attachment. This is what I was saying. We've got to build attachments instead of robots. Attachments for the rails, and to do specific work, machinery to do specific work. So, so what I was thinking is having a magnetically XY grid along a set of rails, and have it magnetically, rather than use pulleys or gears or bearings, rather than travel with bearings and gears, and that it travel with magnetics. So you have like so you really improve the speed of how you can operate. This is like what I was thinking about with cars, how they Tesla tried to make a fully automatic facility. But it's pointing out they didn't really do anything to the car to make it easier to manufacture. There's some simple things that you could do to a car to make it so it's easy to have a fully automated facility. And cars and components. There's certain easier ways, simple mechanical ways to build components and to have the shape of a car, have it easy to assemble into the shape of a car, or into a car if you adjust the shapes of the car. If you adjust the shapes of the components, if you adjust the shapes of the engine, if you adjust the shapes, you can assemble and manufacture cars with a lot more with a simpler automation process in mind, where you're Because when you start using complex robots, things start breaking, right? That's the thing we haven't advanced in is our general design and engineering for things that don't break. We haven't progressed our understanding of what things don't break and what things last and will be good to use in an automated process. We have to build up on what doesn't break and what's good to use in an automated process so we can build automated lines that don't break down and are faster than the human lines. And this is what I was saying with machineries and attachments. They're faster than robots and faster than humans. And magnets are even faster yet. So, and if you assemble things similar to like a 3D printer on an XY grid with magnets zipping across the grid, you have the grid and it's zipping up, moving up, moving up, moving up, and zipping across the grid and pinpointing things. You can assemble whatever component you want in this grid, and pick it up and put it into the engine, and use squares. Being square is probably the easiest way to assemble and automate something automatically and have it being safe and easy to use and easy to build and easy without any problems. So this is about a magnetic XY grid and magnetic XY rail system.